Thank you for coming along to this third after-lunch session here at PyCon. If you're looking for popular terms in the industry at the moment, containers, Dockerizing things, microservices, you've definitely come to the right place. You've come to the right place because our presenter, Dorian Pula, is going to be talking about all of these at the same time. Please make him welcome.
Thank you so very much. Just before we start, just a quick show of hands. How many people have played around with Docker? Oh, wow. OK, keep your hands up. How many of you guys use it for your development regularly? OK. How about testing, like testing continuous integration? OK. And how many of you brave souls actually use it in production? OK, wow, more than I expected. Awesome. So, my talk, Pythons in a Container, is essentially, it's about the lessons that we've learned when Dockerizing Python microservices, and lessons that we actually learned the hard way, because that's the best way to learn anything. So quick little introduction. So who am I? I'm Dorian Pula. I'm a software development engineer at Points. Which means I get to work on developing an e-commerce platform for loyalty programs. So if you're buying, gifting, or transferring points from like an airline or hotel, you may be using our system. And that actually translates into a lot of Flask REST APIs and apps, and I get to work on all of them. And basically the deployment strategy that we have, development and deployment strategy that we have decided to take at Points is actually using sort of a Dockerized microservices approach, and I'll be talking about that today. I'm also an open source contributor. I have my own CMS because we all need one more CMS. It's built in Flask though, not in PHP. I've contributed to Fabric, Ansible, and a little bit of Core Python, and because I have a sort of a healthy interest in working on deployment and infrastructure processes, I've also came up with a bunch of and released a bunch of Ansible roles for Nginx, WSGI, Node.js, and Supervisor. And OK, so let's jump right in. What does this talk about? So as I said, this is sort of the lessons that we learned when actually using Docker for Flask REST APIs and apps. But a lot of the same things will apply for like Django, Pyramid, or Bottle. Basically, anything that you can have a WSGI application should basically work as well. I'm also going to be talking about some of like incorporating the tools that Docker and Docker Compose provides, which basically enable a better sort of DevOps workflow. And about also the usefulness of unlearning some of the sort of regular accepted patterns that we do in Python development, because some of them don't really apply as well when working with Docker. Also, what is this talk not about? So it's not an introduction to basic Docker or WSGI application development, because there simply just wouldn't be enough time to do sort of a tutorial for both. I won't also be talking about Docker Machine, which is a really cool technology, basically letting you link local Docker containers with sort of like remote AWS instances and things like that. But that's a subject in of its own. And I won't get into really advanced Docker wizardry. For that, I recommend actually going to DockerCon, which is actually next week. And if you guys do, you may actually bump into some of my coworkers there. And finally, I'm not going to try to give you an expose on why you must or must not use Docker. Essentially, just use the right tool for the job and understand why you want to use it. However, I will say that Docker definitely provides some really nice things. So let's talk about like why we want to actually use microservices in Docker in the first place. So to illustrate things a little bit easier, let's take sort of a sample situation. So imagine that all of us in this room are tasked with actually building a new application or service that would provide like a loyalty program experience for like Sprint contributors at PyCon. essentially what would happen is that you would earn points per commit or issue resolved, and you'd be able to redeem them for essential sprint goods like coffee, Pop-Tarts, and Dogecoin, all the things that you need to get through a coding sprint. And we'll have the following dependencies, following components. We'll have a REST API. We'll host the front-end application. We'll have some sort of service for handling the redemption of points, user and project registration and linking, and also a database. So if we were to break that up into sort of an architecture, so why would you actually want to, if you were to task out to build something like this, why would you want to use microservices in the first place? Well, if we went with a microservices architecture, we could divide this up into multiple services and have multiple teams working on different services concurrently and using sort of the technologies that they're good at. So some of the benefits of actually going with this type of architecture is that you'd get smaller, less complex code bases, right? Because each one of the services you're working on has only one specific purpose. You would enable greater independence between code bases and teams. So if one team decided to build an application in Flask, that doesn't mean that another team can't build it in Tornado, Twisted, or Node.js or Ruby or whatever. And essentially, it would enable us for more sort of flexible scaling schemes. And not scaling just in terms of production, but also organizationally. Of course, with any technology, there's always, or any kind of architecture, there will be drawbacks. One of them being a distributed code base is harder to think about, harder to infer. It may contain implicit inter-service dependencies, which are not easily recognizable just from looking at a code base. And we would definitely have more complex orchestration, monitoring, provisioning schemes, just because we have more services. Now, if we were to break this out into sort of like an architectural diagram, we could divide up our application into like 3 different REST services. One for like the redeem service, which would connect to external vendors. One for the user and project registration service, and one for the actual app and API. Now you could break it up into various different components, but in essence, that's what you're doing. You're taking an application and breaking it up into multiple different parts. So why would we want to actually use Docker for this? Well, Docker uses containers, which are lighter in memory and in processing than virtual machines. And that's because containers act more like user space instances rather than trying to emulate a full machine. So they'll definitely take less memory and less space because you don't have to emulate a full physical machine. Docker also uses an interesting sort of cached, immutable layered file system, which I'll talk about a little bit later. Also, one of the really nice things about Docker and Docker Compose is just the tooling that it provides. Tooling for basically quickly spinning up various containers or environments. It's very easy to do that in Docker Compose. And also to actually create, share, and publish these images so that you can collaborate across your teams and with other people. And ultimately, it actually just provides a better sort of workflow, a more unified workflow that would replace a bunch of the other tooling that you would normally have, namely things like chroot, LXC, and Vagrant, and so on. So how would we actually develop this? So first thing that we would do is that we want to specify all of our services in one place, just so it's easier to reason about. And this is where our Docker Compose YAML would come into place. So we specify all our services and the environment variables, host names, its dependencies, all that wonderful stuff in one single place. And then we would actually basically start up this entire service just by simply going Docker Compose up. And then that will bring up all of your services, make sure that everything is nicely connected and working, assuming that you got everything right the first time around. And so the Docker workflow is really nice because it ultimately replaces some of the more conventional workflows. So most of you guys have used Vagrant, right, in the past for working with like complex setups for various applications. Well, Docker and Docker Compose specifically, if you put them together, they will actually sort of map one-to-one with the commands that Vagrant would have with ones that you would have in Docker Compose. So things like vagrant up and vagrant SSH and then run an app command, it would basically, it translates into Docker run app command. Vagrant halt becomes Docker stop. Vagrant status becomes Docker PS because, yes, just like as you would do PS in Unix or a Linux system, if you did PS, even without this little Docker PS, you could actually see your Docker processes and the containers actually running on your system. Docker PS just gives you a nice little abstraction for that. You'd have a vagrant provision, which becomes Docker build, so building of your images and your containers. Vagrant destroy becomes Docker stop and Docker RM to remove the images. And just like with Vagrant, how Vagrant handles the creation of base images, you also have similar commands in the case of like Docker images, Docker RMI. Okay. So one of the lessons that that people learn when actually working with Docker is the importance of having good Docker images. So here you have an example of a very simple Dockerfile just for bootstrapping a Flask application using WSGI. One of the things that you'll notice that each one of those steps, the from, run, add commands, they all will create sort of new layers in a file system because Docker uses sort of like a layered file system, which basically builds up your image and then all the layers work together as a sort of a container. The only problem is that each layer takes up a lot of space, right? So what you want, one of the things that we learned is that we want to minimize like the number of steps that have like the separate run steps because instead of having like one layer just for updating like apt-get and then one layer for installing, you really don't care about those two separate layers. You just want one layer that says, okay, bringing my system up to date and install all my dependencies, right? So in this case, we only need to have one command, right? Rather than multiple commands and having multiple layers for each command. And ultimately, you also want to make sure that your layers are cacheable. So what does that mean? Well, that means that Docker, when it's building up your images, it uses the cache layer from a previous step. And it will try to reuse that layer if it finds out that there hasn't been a previous step that has changed or if a particular source file has changed. If they haven't, then it will try to reuse the layers, which means you get a faster setup time for actually doing when you're building your containers. And if you find yourself that you have a lot of sort of like basic setup just to get an image up, you want to look at stuff like base images, especially if you have like, let's say, 3 different microservices and they all use the same sort of setup, whether they be like you have a common Flask or you need Node to be installed. Then it's good to actually include a base image and maintain that. If you're interested in actually maintaining sort of base images that other people can use, then go check out the on-build command, and that will help you build sort of like dynamic base images. And finally, one thing it's not critical, but it's useful when you're actually developing, and that's exposing sort of the ports and the volume maps, just so that you can document how your image is going to work. All right, so that's okay. So far I've really only been talking about like basic Docker stuff that applies to all things, to all different kinds of systems. But what about something that's Python specific and specific to WSGI apps? One of the lessons that we learned is web servers. Well, since you want to keep sort of a little nice, concise Docker images, you don't want to include too much stuff. And one of the things that you don't really need to include is actually including a web server for your image. Instead, you should probably look at using sort of an external proxy, so an external Nginx instance, or having like your own web service container. Rather, if you're just building WSGI applications, then just do the simplest thing and run a simple WSGI app server to actually host and run your Python application. Two of the more popular examples being WSGI and GUnicorn for that. Another thing that is sort of like a common accepted practice when developing complex or just any kind of Python applications is the use of virtual envs. Virtual envs to separate what packages you install in one place rather than having a whole system of very conflicting packages. You use virtual envs. But when you're actually working with Docker, actually, you don't want to use virtual envs inside your Docker container because you don't need them. Ultimately, each container is an isolated system, and so you don't have to manage having separate environments. So just install directly into the system Python site packages. Also save you a lot of time and hassle. All right. Since usually, when you're developing something, you don't always get it right the first time around, so you may have to debug containers or services. Now, normally, if you have a Vagrant instance, you would SSH into this thing, but you don't want to include an SSH daemon into your Docker image because it's just going to get too large. So how do you debug a running container in that case? Well, you can actually use the Docker commands to actually run various commands on a service. So in this case, let's say we want to run bash on a running service. So we could do basically, going back to our Docker Compose example, use Docker Compose, execute the service name, and bin bash. And there's a similar command for just running on pure plain Docker. Similarly, if you want to just inspect what an application's logs are doing, then you could do that using the Docker Compose logs and providing the service name. Now, mind you, Docker only handles standard out and standard in, or sorry, standard out and standard error output, so you can't use any sort of complex logging. Just have your application log to standard out and standard error, and you'll be good. Finally, you want to actually you may want to inspect your running container setup. So you might want to, you can use the docker inspect command, and it gives you a whole bunch of output. It tells you what exposed ports you have, what volume maps, and all that stuff. One of the gotchas I've run into is that you would have Docker inspect produce an incredible amount of output. So sometimes you just want to scale it down and just look at just a particular aspect. So you can use the format command and provide a Golang format string to actually see those things. And a couple of minor tips when coming to persistent configuration and processes. So one thing with volume maps. So you want to use volume maps because you want to, when you make a change to a Docker container and you destroy it, all of those changes are lost. So there are two approaches of actually getting around that. One is to have a volume map, so you have an external host folder where you can dump all of your stuff for your database and whatnot. Another pattern that's often used is actually to have a separate Docker data container that won't go away. In terms of configuration, you should be using environment variables for configuration. Your services are very, single purpose, so they should be simple enough that you can just use environment variables to set things up. You can volume map configs as well, but that may be a warning sign you just have a really large, complex configuration setup, and your configuration may need refactoring. If you find yourself that you need to run multiple processes, you can use stuff like supervisor-d or run it to control multiple processes. However, in a microservices approach, the best way is just to have one type of process that you're running. So you may want to, if you find yourself coming up with complex supervisor-d setups, then you should probably consider refactoring your service into multiple containers instead. Docker and Docker Compose really make testing a lot easier. It'll add consistency into your CI environments, so you no longer have to try to build up, if you're working in with a large build farm, you don't have to make sure that each agent in your build farm has the exact same environment, because it's really simple to set up a Docker host, and then you take your environment with you. Because you control whatever you put into that container. So that means that you can have sort of like repeatable workflows and simpler test processes. And there are a lot of cloud CI options with Docker support out there now. Very quickly, when it comes to tooling, it's probably not a good idea for you to write your own Docker tooling. The Docker commands usually provide enough things for you to work with. Plus, the API, the internal API, has a habit of changing a lot from version to version. If you do decide to actually do something like that, then take a look at Dockerpy. That's a Python client library for working with Docker. But again, you probably don't want to do this. So we've covered sort of like the best ways of doing development. So how do we actually deploy this out into prod, and how do we scale this up? Well, if we go back to the architecture that we selected for our application, while it's a nice way to understand what we're trying to build, this really won't scale in production. Rather, in production, your setup will probably look like this, right? Where you have the multiple load balancers between services. You may have you may find that the application of front end just takes more, needs to handle more traffic, so you'll be running multiple containers over multiple data centers and things like that. So when you look at it, there's a lot of moving parts that you have to consider. And I'm not even putting in things like message queuing, data warehousing, and all that stuff. This is just our basic application, right? This is how it could potentially look in prod. And when you think about it, ultimately, what you're really doing is you're setting up a little private cloud of various microservices. And so there's a couple of things that you have to think about when you're actually doing that. You have to start worrying about like load balancing and network topology. So you have to look at using stuff like HEProxy and Nginx. You also have to deal with provisioning, because you may not Dockerize all of your systems, but you still want to have an automated, repeatable setup for non-Dockerized systems. Or you may even want to just have your Docker containers controlled separately by your provisioning script. So you should probably look at stuff like Ansible, Puppet, and Salt. Please don't try to run your own little Fabric script to get everything working together. There's too many things, too many edge cases that you might run into. You also have to think about monitoring. You have to know, if you're dealing with multiple services, what is the health of your app, what is the behavior of your application, and the system resources on basically all of the systems that you're managing. So suddenly things like Nagios, Pingdom, and New Relic become important. And logging becomes crucial, because in a microservices architecture, you're going to have multiple log streams. And you're going to need to aggregate the various logs and correlate the events so that you can be able to debug when something if something breaks between services, or if basically the bug is not in the first service they have to deal with, but in some lower service along the way. So tools like Splunk and others come in very helpfully. So yeah, essentially, if you go down the Dockerized microservice approach, you have to get into sort of some of the cloud infrastructure. And managing cloud infrastructure is hard. You need a lot of tooling and a lot of automation to get all that stuff into place. And you really don't want to build out your own tools unless you want to support those tools to the end of time. Unless you're a cloud tech vendor, in which case you don't really need to be at this talk. You should be out building awesome cloud stuff for all of us to use. So instead of building your own, you should probably look at using other services, like use something like Docker Swarm or Kubernetes. The OpenStack guys have a pretty interesting compute platform called Magnum. And there's also the CoreOS guys, so if you want an alternative to Docker, there is CoreOS Fleet. All right, so to summarize the lessons that we've learned, microservices and Docker can really improve building and deploying a large, complex system. But neither one is a cure-all, right? There's a lot of things you have to keep in mind. Also, good development and deployment processes matter, because ultimately, if you have a good, smooth development and deployment process, you get happy devs, right? Makes life so much easier. And Docker has a fairly decent workflow that you can use to shape those processes. And you should expect lots of additional infrastructure around microservices, which might make you tempted to actually build your own tooling, but unless, again, you want to support it, don't do so. It's not a fun thing. And even though a lot of the cloud tech vendors are actually pooling their resources, just not to rebuild the same kind of infrastructure tooling. Use Docker containers to do the actual effective isolation, so you don't have to worry about using stuff like virtual envs or any other kind of virtual environments. And ultimately, good app design enables all this. A good app design will be able to work nicely into a Dockerized system without a lot of manual rework. Okay, so there's a couple of interesting resources that I include in the slides. I want to thank Jared Kareem from Mozilla, who presented this really great Django Docker template. So if you are working with Django applications and you want to deal with some Docker Compose, take a look at his example. Also, if you haven't read 12-factor apps guidelines, you should definitely read them. They're really good. And I also built a Dockerized sort of workflow example for my CMS rookeries. It's on a branch, but if you're interested in sort of a simple setup for like building a Flask application with a database attached to it, then go ahead and look at that. So thank you so very much for everyone for your time and attention. Have any questions? Here.
Okay, if you have questions, line up at either of these two microphones. If you are going to stay in the room, or even if you're walking out right now, please keep yourself relatively quiet so that we can still hear the questions being asked and answered. Thank you. Over here.
You mentioned there are a couple different options.
Excuse me.
Yep.
Please, audience, keep the chatter to a minimum while questions are being asked. This is really valuable to the audience at the moment.
You mentioned there are a couple different options for running containers in production. What do you use, and how do you like it?
So right now we're actually manually managing our containers. We're looking into using Kubernetes in the future. It's something that we're still experimenting with.
Thanks.
How do you, if at all, handle database migrations in an environment where you're using Docker for the database?
So database migrations, for the most part, are going to be fairly similar. You still have that whole graduated rollout of databases. You might be able to migrate some of your data running on a separate container, but otherwise it's a very similar setup, right? The same rules for a database deployment and a gradual rollout still apply regardless.
Hi, I was wondering if you have any experience with, say you have 3 services, A, B, and C. A depends on B, B depends on C, and you want to test A and not have to spin up the entire world, basically, to test it.
Yeah. Well, you can spin up the entire world. It's a useful end-to-end test, and sometimes we do that. But ultimately, I would say that using sort of like a stub server to mock out like a service B. If all you want to do is just test service A in isolation, and it's only its dependencies on service B, then it's better to just have like a stub server, something like Montebank. Seems to work very well for those kinds of cases, yes.
Thank you.
We have one more over here.
A couple of things. One thing that you mentioned was that an alternative for Docker was CoreOS Fleet. Well,
Yes.
Fleet is CoreOS's initial offering for a scheduler. So it's kind of like in the same sort of like realm as Docker Swarm. But CoreOS is container engine is something called Rocket, which is
Yeah.
kind of amazing. That's the first one. The second one is that, sorry to say, but a lot of
Is your
things.
second question a question?
It's more of a observation.
Then can we have somebody else? Thank you very much.
Oh, feel free to
Please
talk to
reason-
me
please
afterwards,
reason
yeah.
with the Speaker afterwards. This is time for questions. Thank you. Okay, and with that, everybody please thank Dorian for a fantastic talk. We also have a real person operating the open captions, and we should probably give her thanks as well. Thank the stenographer, please. There